Math. When you need help, you use Minute Math.
Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about mixture word problems. So, if I was given this word problem, 2 meters cubed of soil containing 35% sand was mixed into 6 meters cubed of soil containing 15% sand. What is the sand content of the mixture? So the first thing they tell us here is we have 2 meters cubed, right? 2 meters cubed of soil containing 35%. So that as a decimal is 0.35. So when we multiply that out in that mixture, that means we have 0.7 meters cubed of our mixture. Now that's containing sand, right? So that original thing, 0.7 meters cubed, contains sand. Second one says we have 6 cubic meters of soil that contains 15%. So as a decimal, that's 0.15. Multiply that out, we have 0.9 meters cubed. Now we add these two numbers together, and we have 1.6 meters cubed total of sand that's combined in these two. So now we want to find the total percent content that is sand. So we take the 2 and the 6, we add that together. 2 plus 6, right, gives us a total of 8 meters cubed. So the percent there, we take 1.6 divided by that 8, and that gives us a decimal. So 1.6 meters cubed of sand, the pure sand we found from our ratios here, percents, over a total of 8 meters cubed, gave us a 0.2 as a decimal, or our final answer, which is 20% sand content. 9 pounds of mixed nuts containing 55% peanuts were mixed with 6 pounds of another kind of mixed nuts that contain 40% peanuts. What percent of the new mixture is peanuts? Okay, so let's go start with this. We have 9 pounds. So that's 9 pounds of mixed nuts containing 55% peanuts. So that as a decimal is 0.55. Multiplying that out, that comes out to be 4.95, and that's the first mixture, has 4.95 pounds of peanuts in it. The second mixture contains 6 pounds of types of mixed nuts, and that one had 40% or 0.40 as a decimal, which is peanuts. Multiply that out, and we have 2.4 pounds in the second mixture of peanuts. Add that together, add these two numbers together, and we have 7.35 pounds of total peanuts. Now, we add the two mixtures together. 9 plus 6 is 15. So 9, we add it like this, is 15 pounds. And so combining these two to make a fraction, we want to see what percent of the final mixture is peanuts. So we take 7.35, divide that by 15, and we get a decimal of 0.49, which comes out to be 49%. And so our final mixture contains 49% peanuts. 5 fluid ounces of a 2% alcohol solution was mixed with 11 fluid ounces of a 66% alcohol solution. Find the concentration of the new mixture. So our first thing, we have 5 fluid ounces, first mixture, and that contained 2% alcohol. So that as a decimal is 0.02. Multiply that out, and we get 0.1 ounces of alcohol that was in the first mixture. Okay. Second mixture had 11 ounces or fluid ounces. Okay, and that one contained 66% alcohol, or as a decimal, 0.66. Multiply that out, and we get 7.26 ounces of alcohol, or fluid ounces, was in the second mixture. Add them together, and we get a total of 7.36 ounces of alcohol in our final mixture, which comes out to be a total of 16, right? Add the ounces, 16 ounces total fluid ounces. So to get the final ratio or percent concentration, we take 7.36, divide that by 16, and we get a decimal 0.46, which comes out to be as a percent 46%. And so our final concentration on the new mixture with alcohol is 46%. 16 pound of brand M cinnamon was made by combining 12 pound of Indonesian cinnamon, which cost $19 per pound, with 4 pounds of Thai cinnamon, which cost $11 per pound. Find the cost per pound of the mixture. So, our first mixture of Indonesian cinnamon, we have 12 pounds. Okay, 12 pounds. And that costs $19 per pound. This gives us, when we multiply it out, a total cost, right, for the whole mixture of $228. The second part of, or not mixture, sorry, the second Thai cinnamon, which is 4 pounds, cost us $11 per pound. Okay? That's not $19 per pound if you want to write it like that. 4 times 11 is $44, right? So we have $44 total here. We add that total cost up, and we get $272. Now, 12 plus 4 is a total of 16 pounds, right? So if we want to find the total cost per pound of the mixture, we take our $272, divide that by our 16 pounds, and we get a final answer of $17 per pound for our mixture. Emily mixed together 9 gallons of brand A fruit drink and 8 gallons of brand B fruit drink, which contains 48% juice. Find the percent of fruit juice in brand A if the mixture contained 30% fruit juice. Now that's the final percent, okay? So let's go set up a big equation and let's solve. So we have 9 gallons, all right, 9 gallons of brand A. So we take 9 gallons times whatever A's percent is. Then if we add that to 8 gallons of brand B, all right, so there's a little brand B here. But brand B, they said, was 48% juice. So that is a decimal of 0.48. Then that's going to equal our total, right, combination, which involves a total value of 9 plus 8 gallons. So 9 plus 8 gallons times, they said, was a final thing of 30% fruit juice. So 30% is a decimal, 0.3. Okay? So now let's simplify this up and solve where we can. Now this final thing is going to be a decimal, a percent, and we have to convert it to a percent. So when we write this out, we have, well, 9 times A plus 8 times 4.8, or 0.48, sorry, is 3.84. 9 plus 8 is 17 times 0.3 is 5.1. Now we're solving for A. Subtract a 3.84 to both sides. And we have 9 times A is equal to 5.1 minus 3.84, which is 1.26. Divide both sides by 9, and we get the decimal for A, which is 0.14, which as a decimal is 14%. And so our final answer is the brand A, right? When we mix it up, contained, right, 14% fruit juice. How many milligrams of metal containing 45% nickel must be combined with 6 milligrams of pure nickel to form an alloy containing 78% nickel? So we start with the first thing here. We have X X milligrams, we don't know how much, of metal containing, they said, is 45% nickel. So whatever that total first thing, it contains 45% nickel. So multiply that as a decimal, 0.45. Then it's combined with 6 milligrams containing pure nickel. So that percent is actually 100%, or as a decimal, 1.00. That's going to equal some mixture, okay, some final alloy. Total milligrams we don't know, but we know it's these two combined, so X plus 6 milligrams, multiplied by a total 0.78, which represents a 78% nickel in the final combination. So now we just need to take this equation and solve for X to get our initial milligrams of metal. Okay? So let's kind of simplify this up here. This multiply first part, let's write it as 0.45 X plus 6 milligrams times 100, or sorry, not 100, 1 is 6, is equal to, now let's distribute 0.78 to both parts. So it is 0.78 X plus 6 times 0.78, which comes out to be 4.68. So we're on our journey to solve for X. I'm going to subtract a 0.45 X to both sides. Let's get our like terms together. And then I'm going to actually add, well, let's go write what that is. 0.78 minus 0.45 is 0.33x. I'm going to subtract a 4.68 to both sides. And 6 minus 4.68 is a 1.32. Okay? Now, what I want to do is get x by itself. So I divide both sides by 0.33. And x is now by itself. 1.32 divided by 0.33 is 4. Okay? So our final answer is just 4 milligrams of metal. Okay? If we look back at the problem, they said how much milligrams of metal containing 45% nickel must be combined, right? The problem itself. So 4 milligrams of metal must be combined to our final alloy to contain 78% nickel at the end. 7 liters of an acid solution was mixed with 3 liters of a 15% acid solution to make a 29% acid solution. Find the percent concentration of the first solution. So let's make an equation out of this word problem here. So we have 7 liters we're starting with, 7 liters of some solution, and we don't know what percent of that is acid. We know we're combining that to the second solution, which is 3 liters, and that one contains 15% acid, or as a decimal, 0.15. When we combine that all together, our final volume is a 7 plus 3 liters, and that's going to be multiplied by, or has a 29% concentration, so multiply that by 0.29. Okay? So now let's simplify this. So 7x plus 3 times 0.15 is 0.45. And 7 plus 3 is 10. Multiply that by 0.29 is 2.9. We're solving for x here. Okay, so we had to subtract a 0.45 to both sides. And 7x just comes down. And 2.9 minus 0.45 is 2.45. Divide both sides by 7. We're going to get a decimal here of x equals 0.35. And that as a decimal is 35%. And so our final answer here is our first solution contained 35% acid. 9 gallons of a sugar solution was mixed with 6 gallons of a 90% sugar solution to make a 84% sugar solution. Find the percent concentration of the first solution. So, what I want to do is make that into an equation here. So they tell us here that the first solution of 9 gallons, okay, contains some sugar solution. We don't know that. So let's label that X percent of that. We're combining that with 6 gallons, which we know to have a concentration of 90% sugar solution, right? Multiply that as a decimal as 0.90. That's going to equal our total solution. So if we add 9 plus 6 here, that's our total gallons. And that final concentration is 84%. So as a decimal, 0.84. Now we have an equation. We're going to solve for our X percent. So 9x plus 6 times 0.9 is 5.4. 9 plus 6 being 15 times 0.84 is 12.6. So our journey to solve for x, we subtract 5.4 to both sides. And we have 9x by itself here. 12.6 minus 5.4 is a 7.2. Divide both sides by 9. And we're left with x completely by itself. 7.2 divided by 9 is a decimal of 0.8, which is, as a percent, 80%. And so our final answer here, the first solution contained 80% some sugar solution. A metallurgist needs to make 12.4 pounds of an alloy containing 50% gold. He is going to melt and combine one metal that is 60% gold with another metal that is 40% gold. How much of each should he use? Okay, so this is a little tricky. Our first metal, let's call it metal A. So we have metal A here. That one contains 60% gold. So as a decimal, 0.6. That combines with our second metal, metal B, which contains 40% gold, so as a decimal, 0.4. That combination, we need to make a total amount of 12.4 pounds, and that final amount needs to contain 50% gold, so as a decimal, 0.50. Well, we have an equation here, but we have two variables, and I know I can't simplify or solve actually for any one of these variables specifically without a second equation. So we need to make another equation, which I'll put up here. One thing we know is A plus B, the pounds of our metals combined, is a total of 12.4. So a little side note here, make a little note to myself here. Okay, we know that A plus B equals 12.4. So if I subtract B to both sides, that means A is just 12.4 pounds minus B, whatever the pounds of B metal is. Okay, that's going to help us. We're going to need this coming through. So let's first simplify that first equation as much as we can. Okay, and we'll kind of simplify it. We're going to put this in that same step. We know A is 12.4 minus B. So instead of A, I have 12.4 minus B times that 0.6 here, plus 0.4B, I'm just rearranging that, and 12.4 pounds times 50% of that, all right, 0.5, is 6.2. Okay, so now we have an equation that just has one variable, so we can solve for that variable, B. So we're going to distribute the 0.6 of both parts here. 0.6 times 12.4 is 7.44. Minus 0.6b, right? 0.6 times b, plus 0.4b equals 6.2. We can subtract a 7.44 to both sides. And that gives us 6.2 minus 7.44 and negative 1.24. Combine these two together right here. Negative 0.6b plus 0.4b is a negative 0.2b. Divide both sides by negative 0.2. And remember, by dividing by the negatives here, it becomes a positive. B is now a positive 6.2, and that's million pounds. So now we know our second metal, which is a 40% gold concentration, or mix containing 40% gold, is 6.2 pounds. We use this equation here, right, to get what A is. So A equals 12.4 minus 6.2. And A, our first metal, 12.4 minus 6.2 is also 6.2 pounds. So our final answer, write it out here. We have 6.2 pounds of 60% gold and 6.2 pounds of the 40% gold. And that is our final answer. Brand X sells 21 ounce bags of mixed nuts that contain 29% peanuts. To make their product, they combine Brand A mixed nuts, which contain 35% peanuts, and Brand B mixed nuts, which contain 25% peanuts. How much of each do they need to use? All right. So, first thing, we have Brand A. Right, Brand A in ounces contains 35% peanuts. So multiply as a decimal, 0.35. When we combine that with Brand B ounces, which we don't know, but that contains 25% peanuts. So as a decimal, 0.25. That's going to equal our final amount, Brand X. So this is Brand X in ounces, but we already know what that amount is. That is 21 ounces, they told us. Okay? And the final Brand X contains 29% peanuts. Okay? And that is a decimal multiplied by 0.29. Okay? I almost got ahead of myself. But notice that we have an equation here with two variables, A and B. When we have that, we can't solve that directly. Okay? So what we need to do is find another equation. Well, this is fairly simple. We know that A plus B ounces is 21. So a little note here. A plus B is 21 ounces, right? And so if you want to figure out what, let's say, A ounces is, A is equal, subtract B to both sides, 21 minus B. Okay? So it's kind of good to know that right there. And so on our next step here, we're going to take that fact and substitute A in here. 21 minus B in for this A. All right? So let's go simplify. 21 minus B times 0.35. Now, this is the substitution method, right, for solving a system of equations. Fun fact. Plus 0.25B, rearranging that. And that's equal to, well, it's 21 ounces times 0.29, and that's 6.09. All right? Keep going. We distribute here. 0.35 to both parts. Well, 0.35 times 21 is 7.35 minus 0.35b plus 0.25b equals 6.09. Let's get b's by itself. So we subtract a 7.35 to both sides. And we're left with, on the right here, 6.09 minus 7.35, a negative 1.26. We combine these two together here. It's kind of a weird combination. The negative 0.35b plus 0.25b is a negative 0.10b. Divide that to both sides, a negative 0.10. The negatives cancel, making it a positive. And B equals negative 1.26 divided by negative 0.10 is a positive 12.6 ounces. So we got bag B has 12.6 ounces, but we need to find bag A. Come here to our other equation we found and plug 12.6 in for B. So A equals 21 minus 12.6, and we get A is 8.4 ounces. And so our final answer, by combining everything, we have 8.4 8.4 ounces of brand A and 12.6 ounces of brand B. And there is our final answer.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.